I'm frequently asked, what is it that you actually need? What is cybersecurity in terms of, if you wanted to be a cybersecurity person, what do you need? What do you do? Very frequently, does that require a computer science degree, for example? So I'll give you my thoughts. Others may have different opinions, but I actually look at cybersecurity and I use the term cyber professional, which to me is both an art and a science. The science very frequently is computer science, but the art is something different. The art is actually understanding how systems are attacked, how they're defended, how they're managed, how to evaluate risk, how to architect them. It's all a very large piece of the puzzle. For example, it's not necessary to even approach computer security from a technical standpoint. Though I think most opportunities are on the technical side, there clearly are those who manage computer security and aren't the people moving bits and bytes. Those people may have business degrees, they may have systems analysis degrees, they may have other degrees. I actually started out in physics, as an example. The people who come from the other side can add value to computer security by understanding computer security's context in the larger business sense. For example, understanding business processes, how breaches or faults in a particular process constitute a set of risks, how to manage those risks and mitigate those risks. Simple example that's not a technical piece, but what data do I actually need to keep about people? That's a business decision. It is a business decision that you have to weigh the risk were that information to be disclosed. That's not a technical thing. That's a combination of business, practice, and law, for example. Clearly on the technical side, the more technical you are, generally speaking, the better. A lot of people start with computer science degrees, but again, that doesn't necessarily give you an in. There are lots of people with computer science degrees that really don't know how systems are attacked, or thus how they can be defended. And both of those are actually critically important. I think among both groups, I could say that there are some fundamental things that you probably should know to get anywhere in computer security. And general study on your own or through an institution can probably get you there. Simple example is you need to understand what security technology there is available now, such as firewalls or spam filters or things of that sort. How they work roughly, not to great technical lengths, what their advantages, disadvantages are, what their weaknesses, what their strengths are. So you could look at that both in, as the hardware context around normal computer security functionality, but also the business processes on how do I actually develop an identification and authentication process within a company or a business. What are the procedural weaknesses there? And a real good example, I do a lot of security evaluations at companies. And while most companies have pretty good processes, or are excellent in many cases, for enrolling new employees and getting their credentials established and their accesses established throughout whatever the corporate entity is, most of them don't do such a good job at disenrolling those people if they change jobs or moving those credentials, or even if they leave in some cases, remembering to get rid of them. Those are business processes. It's not a particularly technical issue, but it is equally as important. In fact, most breaches right now occur because someone opened an email that they should not have opened and executed something in it that they should not have executed. This is not a technical problem. This is a training issue. So clearly there's a large range that can be applied to computer security. If you do go through a technical track, then you need to understand the basics of how hardware works, what its limitations are, and what it can and cannot do, how to go about programming it. I think as a minimum, you certainly have to be able to program, at least to some extent, even if it's just shell code. But you have to be able to understand how tools work and how to write tools, and what those tools can and cannot give you. And obviously, the more study you have, all the way to the internals of the operating system itself, of whatever flavor you're working on, the better prepared you will be. I think it's useful to understand in terms of software how compilers work, for example, because it turns out that how code is laid down in software and how it's put into hardware, frequently that's where programming errors occur and make things available that should not be available to outside entities. So understanding that's actually fairly important. You have to understand the basics of networking, what you can and cannot connect, why you should be wary of some things, what is truly available and not available. A real simple example is a lot of data that is stolen nowadays, sort of the higher end type of data exfiltration, uses odd protocols as a way of shipping data out. For example, packing stuff in DNS.text records. Well, you have to understand what DNS is, what the options are, and then if you were monitoring a network, looking at that option and going, that's a very odd thing to have happen because we shouldn't be using that option from this institution. So it's a combination, I think, of technical experience and business experience that is the best piece for computer security. The problem is, where do you go about getting all that? Obviously, if you're a CS degree, you get from a university, and business degrees you get from a university. But the bit about knowing where to look and what to look for, the artifacts of attacks, for example, how adversaries will attack your system, how they move around in it, that is the art. And that's teachable. Traditionally, the only people that taught that were governments, either the intelligence communities or the militaries of governments. Now there are some organizations that practice that art in a commercial sense, typically large financial institutions, telecommunications providers, the computer companies, i.e. Microsoft, Google, Amazon, etc. People there practice these arts. You can go to work there and, if you will, apprentice to learn them. Now I think there is a recognition that these arts are important, and I think you're going to be seeing more and perhaps better ways to acquire the art part of being a cyber professional. And indeed, I think what you're listening to now is part of trying to get you in that direction.